Hello, everybody. In our last video, we learned how to use the statistics to measure the central location of the data. And so that is one of very important piece of information you have to report if you try to use statistics to summarize your data. We emphasize the advantage and disadvantage of the three different statistics, mean, median, mode. So that's something you have to keep in mind. Because when you work on the real world data, you actually have to be the one to identify the right statistic to measure the central location. And then hopefully you watch the video on how to use Excel to generate those three statistics. If not, maybe you watch this one first, the how to use the statistics to measure variability, and then watch the computer skill videos. And so let's look at what would be the possible variable statistics you can use to measure the variability. And here we're going to talk about these four: range, variance, standard deviation, coefficient of variation. I know many of you guys are very familiar with the range. Therefore, we're going to go through it very quickly, but I will emphasize the weakness and the strength of using range to measure the variability of the data. And then we're going to look at a variance, and I will show you the formula, and I will show you the example to do the manual calculation. Keep in mind, however, we're going to use Excel to do those calculations. The reason I show you the example again is to help you to understand why certain statistics is better than others. And then after that, we're going to look at the standard deviation. I'm sure you are very familiar with standard deviation, but I want to help you to build a connection between variance and the standard deviation. And the last one we're going to look at is coefficient of variation. And then some students might not familiar with the coefficient of variation. I will explain why this statistic is useful in some situation. So first of all, let's look at the range. So what is range? The range of the dataset is the difference between the largest and the smallest value. Basically, you go to your dataset to find the largest value and the smallest value, and if you find the differences, and you will be able to calculate the range. So using the same example we worked on a few minutes in last video. So look at the first case, 1, 2, 3, 4, 5. So the smallest value is 1, and the largest value is 5. So the differences will be 4, right? So the variability of this data set is 4. However, there is an issue when you're using the range to measure variability. So I want to show you the problem by looking at the second example. So 1, 2, 3, 400. What's the range? So the range is 100, and then you'll think, oh, this data have huge variability. The question is that true? If you really go further, go back to look at your original data set, 1, 2, 3, 4, 100. So the majority of the data are very close to each other, except the last one, which is the largest one. So this is the very extremely large value. That's make range is very biased. Make a range is an improper statistic to measure the variability because this value is very large. So therefore, that is what I want to point out when we look at the statistic using range to measure the variability. So range, the good thing for range is very, very, very simple. So this is the simplest measure of the variability. And the problem is it is very sensitive to the smallest and the larger data value. The reason is because when we calculate the range, we only use the smallest and the largest value to calculate the range. So that's the problem. So since range doesn't work well when we have extremely small and large value, so what would be the more proper method? So since range only consider 2 value from my data set, so how about we consider all the values, and so that we can be more completely consider on my data set and to more properly measure the variability. Therefore, the statistician generated another statistic called a variance. So what is variance? So the variance is the measure of the variability that utilize all the data instead of just 2. They use all the data. So it is based on the differences between the value of each observation, which is xi, each observation, and the mean. The variance is useful in comparing the variability of 2 or more variables. So let's see what exactly variance means. Like I said, the variance showing the differences between each observation to the central location. That makes sense, right? That's basically what variability means, is how the data is spread out from your central location. So that is how the variance is calculated. To calculate this variability, what we do is the average of the square differences between each data value and the mean. So we have two formulas. So one is for sample, one is for population. Let me explain the sample first and then showing the difference between sample and population. So look, the numerator is xi is each individual observation, and x bar is what we just learned in the last video. So that's the sample mean. So the differences between these two, and then divide by the sample size minus 1. And then we're going to sum all the square the difference together, and then that's what we are doing. So some students are going to ask, why we have to have this square? I will show you the example pretty soon, why this square is so important. Without square, what's going to happen? And look at the difference between sample and the population. So the difference besides notation is this denominator. So for the sample, we're using n minus 1. For the population, we use n. So if you are taking some advanced statistic and you have know what is called degree of freedom, so when we are doing the sample variance, we already use the data once to calculate the mean of the mean. So therefore, we lose 1 degree of the freedom, 1 degree of the freedom. Therefore, we have to use the number of the observation minus 1. However, for the population, we consider the mu is the population. We knows it. So we are not estimating it. So therefore, we are not losing any degree of freedom. So therefore, the degree of freedom still be n. But you don't have to understand what I just said. But you need to know the sample variance and population variance will be different value. And so I will show you on the Word document and give you example regarding how to calculate variance and why we have to square that difference. Okay, let's look at the same example we used to calculating the mean, the sample mean. So we're still treating this data as our sample data, and therefore based on the data, we're gonna calculating the variance. Again, the reason I show you the formula is because help you to understand the rationale behind it. And during the whole semester, we're actually gonna focus on Excel. So this is the formula we saw on the slides to calculate the sample variance. I need to correct one mistakes. So this is standard deviation, the sample variance equal to the each observation minus sample mean and the square, and then divide by sample size minus 1. So if we're using the first sample data 1, 2, 3, 4, 5, and then how we're gonna use this formula. So what happened is the numerator will have x1, which is the first observation 1 minus the sample mean we calculated is equal to 3, and so minus 3 and then powered by 2. And then so this is the first square difference, right? So then you're going to do the same thing for the second observation, 2 minus 3 square, and then plus 3 minus 3 square, and the plus 4 minus 3 and the plus 5 minus 3 square. And then all of this is going to divide by the sample size equal to 5 minus 1 equal to 4, right? So this is how we're going to calculate the sample variance for this case. And then, so the numerator will equal to, so 1 minus 3 equal to negative 2, powered by 2 will equal to 4, right? So 2 powered by 2 equal to 4. And then plus 2 minus 3. So 2 minus 3 equal to negative 1 and powered by 2, but then you end with 1. And then 3 minus 3 equal to 0, and 0 powered by 2 equal to 0. And then plus 4 minus 1 equal to 1, 1 powered by 2 equal to 1. And then the 5 minus 3 equal to 2, 2 powered by 2 equal to 4. And so this one will divide by 4. And so therefore you will equal to 10 divided by 4, right? And then you equal to 2.5. So the variance for this case equal to 2.5. So the reason I show this calculation is because I want to ask you to think about if the formula itself has no square on the top. So no square. So you don't square the differences. What does that mean? So let's see if this formula has no square when you're calculating the difference. So you basically adding the differences together. So what you will end up is, will be basically 1 minus 2, no square, no square, no square, and no square, and then no square, right? And so if that's the case, so your numerator will become -2 plus -1 plus 0 plus 1 plus 2, right? So that's what happened on the numerator, and divide by 4. So if you look at the numerator, -1 and +1, they cancel each other. Sorry, -2, +2 cancel each other, -1, +1 cancel each other, and a 0. So your actual numerator becomes 0. 0 divided by 4 will equal to 0. So which means if you don't square it, in this case, your variability equal to 0 basically means your data has no variability. If you go back and look at your original data, we do have variability. So obviously this answer is wrong. It shouldn't be 0. We do have variability. What's the problem here? The problem here is without the square, the negative value and the positive value, they will cancel each other. Therefore, we underestimate our variability of the data. Therefore, for this calculation, we have to including this square, okay? So it has to include the square. So therefore, the variability, if you're using the variance to measure this data, is 2.5. So some student might ask me, oh, Dr. J, my data is 1, 2, 3, 4, 5, and then mean equal to 3, but my variability is so huge, the 2.5 is almost equal to my mean. So that's the problem I want to point out if you're using the variance to measure the variability. So that is, the variance actually, we're exaggerating the variability. Why? Because look, 1, 2, 3, the difference is just a two number away from the center, right? 1 is just 2 numbers away from the center. 2 is 1 number away from the center. However, after you square the differences, the 1 becomes 4 number away from 3. And so that's exaggerating the differences between observation to center. Therefore, the 2.5 can measure the variability, but this variability will be exaggerated. So how can we fix this problem? That is what we will talk about our next statistic you can use to measure the variability. So that is the standard deviation. So the standard deviation is developed based on your variance. If you take the positive square root of the variance, we just calculated, and then you will be able to get the standard deviation. So the reason we use standard deviation, not only because they were not exaggerating the variability, but also it is measured in the same unit as the data, so that this making this statistic more easily interpreted than a variance. That's why at the beginning of this video, I asked you about a different kind of statistic. How many of the statistics you still remember? I believe most of you guys will remember range and standard deviation. That's not surprising me because standard deviation is more proper than the variance to measure the variability. But you have to know the relationship between the standard deviation and variance. So to put what I said into the formula, so we are using the small s to representing the sample variance. We're using this Greek letter sigma to representing the population standard deviation. So we are taking the positive square root. So in the previous slides, we learned that the sample variance and population variance, when we are calculating that, actually we end up with different numbers. Therefore, the standard deviation that is based on the variance will end up 2 different outcomes for sample and population. Therefore, later when we look at Excel, we actually have 2 different methods, 2 different formulas for sample and population, for standard deviation and variance. So, any questions? If you have any questions, feel free to email me. and or leave the or just join my office hour. And so the last statistic we will learn to measure the variability is called coefficient of variation. So the previous statistic we learned that we are not considering a central location, which sometimes is very kind of important. So sometimes you want to have a large central location, but a small variability. So for instance, um, some people, if you're invest stock, you should know what is blue chip. And so most financial planner will tell you that invest on the blue chip never usually is a good advice, especially during the unstable economic situation like now, COVID-19. Why? Because for the blue chip, usually they are giant company, giant corporation like a Google, and so their stock usually have a relatively average price. So that is a central location, large central location, and the company usually running very stable, which will result in a smaller variability. So that would be considered as a good stock to invest. So for the coefficient of variation, this statistic we created to measure variability of the data, not only just consider variability, but also consider relative value of the central location. So the coefficient of variation indicate how large the standard deviation is in relation to the mean. Therefore, we actually gonna using the combination of the standard deviation and the sample mean to create this statistic. So the numerator is the standard deviation and denominator is the mean. And so keep in mind that the sample and the population coefficient of variation will be different. The reason is the numerator standard deviation are different for sample and it is for the population. So remember, this is the formula we will use. Actually, we have to manually calculate it use Excel. You won't be able to find any already made Excel formula to calculate coefficient of variation, but you just need to know coefficient of variation is another statistic you can use to measure the variability. So to summarize about the statistic you can use to measure variability. Personally, I prefer standard deviation, coefficient of variation. However, you have to know that variance and range both works. And so for range, you have to know it's very simple. However, it's very sensitive to extremely large and extremely small value. So in